Okay, so we get this surprising result for a right triangle. The first thing we got was the radius of the inscribed circle. Sorry, I forgot to draw the circle. Was a plus b minus c over 2, which is a very straightforward formula, right?
Yeah.
So if I gave you a 3, 4, 5 triangle, what's the radius of the inscribed circle?
It's 1.
It's 1. You just have to do 7 minus 5 divided by 2. You don't have to even do any of this complicated math. But it turns out, for a general triangle, we get S times R as the area, or R equals the area divided by S. For a right triangle, that's 1/2 base times height, A times B, over 1/2 A plus B plus C. So this expression here must equal this expression here, which is not at all obvious that those are equal, right?
Yeah.
Okay, and they're probably not equal in general, but they seem to be equal for a right triangle, and we have to figure out why. So what do you think we need to do here?
Well, we could simplify this formula. We can cancel a half.
Okay, so we would get A, B over A plus B plus C
Equals this.
equals A plus B minus C over 2. Alright, what would you do next?
Well, getting rid of the denominators seems like an interesting idea, but well, if we multiply by 2, it's not going to be too complicated.
Okay.
But if we multiply A plus B plus C times A plus B minus C, that might get complicated. Because we multiply by this to clear the denominators.
Okay. Well, do you want to do it or do you want to not do it?
It might help.
Okay. Don't just, there's, what else can we do, right?
Yeah.
So we get 2ab, and I'm sorry, I'm just going to erase it, equals a plus b minus c times a plus b plus c. Do you see an easy way to multiply these two things together?
Well, this sort of looks like a difference of squares.
Okay, where we replace a plus b with x.
And C with Y.
Okay, so this looks like x minus y times x plus y, which is what? What do I give
Which is
my
x squared minus y squared.
X squared minus y squared. See, it does look like it's going to be x squared minus y squared. So what's x?
X is AB, or A plus B.
Okay, so this thing equals a plus b squared minus c squared. So actually multiplying this out, if you did it term by term, it would have been gruesome.
Yeah.
But a simple observation that this looks like a difference of squares where a plus b is x and c is y gives us this, so this is 2ab. Alright, what are you going to do now?
Well, we need to get an A, we're going to get an A times B in here.
Alright, so that makes you think the next step should be what?
Should be multiplying this out.
Alright, so 2ab on this side equals what?
Equals A squared plus 2AB plus B squared minus C squared. Hey, we have a sort of A squared plus B squared. Well, if we subtract the 2AB and add the C squared to this side, then we get A squared plus B squared is C squared.
Is that true?
Yes, that's the Pythagorean theorem.
That's the Pythagorean theorem. So, are these two expressions equal to each other for a right triangle?
Yes.
Indeed, they are.
Because this is a wacky way of writing the Pythagorean theorem.
Right. So, isn't that incredible? That the first thing we did, getting this formula for a right triangle, the second thing we did was getting this formula for a general triangle. Sorry. This formula for a general triangle, this formula then for a right triangle.
Yeah.
Because the area is not 1/2 AB for a general triangle. But then it just simplifies right there to the Pythagorean theorem.
Yeah.
So those two formulas are the same for a right triangle. That's pretty cool. And that's some pretty neat geometry, and shows you how a little bit of algebraic insight can help you with geometry. Most of the time, we're going the other way around. We're looking for geometry to understand the algebra. Here, the algebra helped us understand the geometry. It's pretty neat.
Yeah.
Good job this morning, hon. Good job.